see. A gun fires a bullet vertically upwards with a speed of 256 meters per second, and it takes the bullet 18 seconds to reach its maximum height. Ignoring the drag force, how long should have it taken to reach its maximum height? So it should take U 256, B 0, A minus 9.81, T we don't know is what we want, S we don't know, B equals U plus A T. So it should have taken 256 divided by 9.81. It should have taken 26.09 seconds. That's how long it should have taken. Including the drag force, what was the effective deceleration rate? So, in reality, it only took 18 seconds to reach the maximum height, which means it only took 18 seconds to come to rest, which means it's decelerating faster than 9.81, which means there is more than just gravity acting on the bullet in the downward direction. It's gravity and a drag force from the air. What was the effective deceleration rate? So F equals ma. Well, actually, no, we don't need that yet. Just UVATS again. The only difference here is the A we don't know. I'm expecting it to be greater in value than 9.81. But the T we do know is 18 seconds here. So if we go with V equals U plus AT, then the A here is minus 256 over 18. That is 14.222 with a minus. Okay, so going decelerating faster than 9.81 meters per second squared. Okay, what was the value of the net force on the bullet on the way up? So the net force is just ma, and the bullet I think is, don't actually say it in the question, so I'll have to put in a reasonable value, 50 grams I guess. Let's see, 42 grams we'll say. Okay, so that is 0.042 times 14.22. And the force acting on the bullet is 0.597 newtons. Okay. What was the value of the drag force on the bullet on the way up? Okay, so if we're looking at the bullet on the way up, there's two forces acting on it, weight and the drag. These two forces together make up 0.5973. The drag force will be 0.5973 minus the weight, which is 0.5973 minus m, 0.042 g. Okay. So that is 0.185 newtons of drag force. Okay, when the bullet reaches the maximum height, it begins to fall and reaches a terminal velocity of 25.6 meters per second. How long until it reaches this velocity? Okay, so now the bullet is at its maximum height, so the U is 0. It will fall until it reaches its terminal velocity, which in this case is minus 25.6. A we don't know. T T we don't know, and S we don't know. So let's see. Yeah. In the question I tell you, you can approximate the drag force as being the same value as before, so we'll have to work out the A. So as the bullet is falling, there's two forces acting on it, the weight and the drag force. So if we go with F equals ma, the A will be F over m, and the A should be negative, meaning that the W should be bigger than the D. So if I do D minus W, that should be a negative, the total force acting on it. So that would be our previous answer minus the weight, which is 0.042 times 9.81 all over 0.042. So let's see what we get. Oh, that was already there. 0.042 times 9.81 negative, yep, 0.042. So that is minus, yeah, so not decelerating as fast as before, minus 5.398. So not as much as the usual 9.81 because of the drag. Okay, and I am looking for the T. So the time equals, we go with V equals U plus A T. Okay, so 25.6 divided by that. The time here is 4.74 seconds. Okay. And then lastly, what was the time of flight? So we need to get the time now. The bullet hasn't reached the ground yet. In fact, I should work out how far it has travelled in the previous part. So that's S equals UT plus a half AT squared. So for part S here, see what we get here. U, which is 0. Okay, good. So then a half A T squared. And this is all minus. So that's 60.7 meters minus. So how much further does it have to go? Well, we have to work out what the maximum height is, which we've not done either. So if I go back to the very start and go with UT plus a half AT squared again, UT, wrong one here, UT, which is 18, plus a half A T squared. So the maximum height here is 2304 meters. So that means this still has minus 60.7, still has quite a ways to fall. 2244 meters to fall. Now for this remaining part of the flight, it's moving at a constant speed because, like we saw in the parachute question, the drag force can't not because of the parachute question. In the question I said the terminal velocity is 25.6. So at that point it means the drag force and the weight have equalized and it's not continuing to speed up as it falls. So So it's traveling at a constant speed of 25.6. So using distance, speed, time, it's 2244 divided by 25.6. 87.6 seconds. We have to add on the 4.743 it took to reach the terminal velocity, and in the first part it took 18 seconds to reach the maximum height. So 18 plus 4.743 plus 87.6, total is 110 seconds. Okay, 110 for that last one there.